Soviet Sukhoi 27 fighter interceptor. NATO codename Flanker. U.S. Air Force F-16 Falcon fighter. U.S. Navy F-14 Tomcat fighter interceptor. U.S. Navy FA-18 Hornet fighter. U.S. Air Force F-15 Eagle fighter. Soviet MiG-29 fighter. NATO codename Falkland. These 6 airplanes are the ones intended to rule the skies, the top-of-the-line fighters from the world's 2 major air powers. They are lethal fighting machines with awesome firepower and weapon systems. These Soviet and American fighters have had no reported encounters with each other. And in this era of Soviet glasnost, it's more likely to find them flying in a friendly formation than dogfighting over Eastern Europe. Like when U.S. Air Force F-15s calmly escorted Soviet MiG-29s through Alaskan airspace on their way to a recent Abbotsford air show and handed them off to Canadian CF-18As. It was a measure of military and political cooperation almost unimaginable for the previous 3 decades. And yet, in the months before and after these friendly flights, and even today, pilots from both sides train for the unlikely eventuality that they would have to face off against each other and launch the missile or pull the trigger. Typically, Soviets and Americans perceive each other as the enemy. In reality, however, while it may be U.S. and Soviet-made airplanes in a dogfight, the chances are slimmer today that American and Soviet pilots will be at the controls. More likely are conflicts like the one over the Mediterranean in early 1989, when a pair of patrolling Navy F-14s encountered a pair of aggressive Libyan MiG-23s, as seen in this simulation. The Libyans, coming head-on from a higher altitude, kept on closing the gap, even as the F-14s jinked repeatedly away from a confrontation. Now, from actual F-14 gun camera footage, listen to the critical moments of the fight as missiles are fired, and watch the shadowy images of a MiG-23 during the encounter.
4 miles.
Okay, he's got a missile off.
Breaking right.
Good hit on one.
Roger that. Good kill, good kill.
I've got the other one. Select Fox 2, select Fox 2. I got Fox 2.
Coming hard, stop.
So, shoot him. I got a tone.
Got the second one.
I got the second one on the nose right now.
Okay, I'm high cover on you.
Lock him up. Lock him up. Bam, shoot him, Fox 2. I can't, I don't have a tone. Select. Good kill, good kill.
Okay, good kill. Pilot ejected.
Richard Borowski is an Air Force test pilot, fighter pilot, and director of the Flight Dynamics Lab.
The Mediterranean is indicative of what we might expect in a third world situation where you don't know when an engagement starts that it is in fact going to be a hostile engagement. 2 airplanes point their noses at each other, and if one of them decides that it is going to be a live engagement, the other guy has no way out except to win.
Winning, a painfully obvious goal in the design of any airplane whose mission is air combat. It's no wonder that the modern fighters from the USA and the Soviet Union tend to look so much alike. Yet each has a role, each has strengths, and while they may not be obvious, each has its vulnerabilities. One factor all designers of modern fighters seek is agility.
In a typical air-to-air fight, you will move very rapidly from one end to the other of the flight envelope. You'll move in altitude, you'll move in G, you'll move in speed. And the airplane that is able to make those movements most precisely, most quickly, is the airplane that is probably going to prevail.
And if the pilot can't outfly his adversary, his next goal is to outfly any missile that's launched at him.
Certainly, in the air-to-air business today, we think of the primary threat and the primary weapon as being the long-range, high-technology, radar-guided missile. And that's the weapon of choice. An air-to-air missile in engagement flies at much higher speeds than the airplane flies. the missile also has relatively small wings. Once that missile is launched, it's another airplane coming at you. It has areas of advantage and disadvantage. Its area of advantage is speed, its area of disadvantage is maneuverability. If you can maneuver harder than it can, you can cause it to miss you. If you can maneuver hard and cause it to dissipate its energy in attempting to maneuver, you can cause it to miss you. And more agile airplanes are more effective at doing that.
Borowski offers his pick for agility.
And probably the outstanding example flying today in the U.S. is the F-18. The airplane rolls well, it has good high angle of attack flying qualities, it accelerates well, it decelerates well. The pilot is generally feels very precisely in control of that airplane.
Others, however, have their own preferences. Mikhail Simonov, general designer for the Soviet Sukhoi Design Bureau and a member of the People's Party Congress, spoke of the agility demonstrated by the Su-27's unique Cobra maneuver.
This case is quite simple. The pilot shows Cobra and let the people compare and see if there is any other aircraft who can do the same from the point of view aerodynamics and performances.
At McDonnell Douglas, Irv Burroughs, chief test pilot during F-15 development during the early 70s, sees the Su-27 a little differently.
Our speculation is that it's not as good at handling as the F-15. It looks like it's not as crisp as it maneuvers. It has the maneuvering capability, but it's not as crisp in terms of tracking a target or stopping at a given bank angle and that sort of thing. But again, that's speculation to some extent.
The F-16 is the smallest and lightest of the current fighters. Harry Hilliker, the key designer of the airplane for General Dynamics, sought to make it especially agile.
Okay, the F-16 was the first operational airplane to have relaxed static stability or to fly unstable, statically unstable, not dynamically unstable, and has proven to be no difficulty and received with great enthusiasm. If you make something too stable, why, it becomes hard to control. It won't move. It's like inertia on there. So the more stability you have, the more difficult it is to make it move in whatever direction you command it to move.
This Soviet informational film gives a pilot's perspective on the MiG-29's flight capabilities.
It is easy to fly the plane, and it didn't take me much to retrain. I didn't need to take special flights at test planes, which is set and started flying. There are no difficulties involved. As regards aerobatics, it is not as difficult as with previous fighters, like MiG-21 or MiG-23. It is especially easy to land the plane. This is a very good plane, and I think it fully meets its requirements.
The Soviets have begun to open their aviation doors to the West, and each day we gain further insights into their airplanes, their designs, and how the airplanes fit their defined roles and limitations. The Soviets have brought large contingents of fighters and transports to air shows, and just recently allowed Aviation Week video onto an active Moscow area air defense base. A fundamental tenet for the Soviets is defense of the motherland, the vast territory of the Soviet Union, which spreads across the bulk of Europe and Asia, encompassing 11 time zones with torrid deserts in the south and frozen tundra in the north. They anticipate quick, high-attrition air battles and expect their airplanes to be able to operate in any climate from unpaved surfaces or ice or snow-covered runways. Soviet doctrine stresses short-term reliability and quick readiness of the aircraft fleet, and they expect this with minimum maintenance and service in the field. They accomplish their goals through simplicity as compared to U.S. designs. Dick Ward, an aircraft designer and analyst and teacher of Soviet logistics for the Defense Department, says that in the USSR, fighter construction may appear to be lacking in attention to detail.
They figure that not only must you build your aircraft in peacetime, but also has to be built in wartime under the wartime conditions, including the poorly trained cadre that you would have available to you at the time that you're building the aircraft in wartime. Also due to the lack of vendors, the infrastructure that would be disrupted during wartime. And so the technologies applied to Soviet aircraft are based on many criteria. Many Western observers have seen Soviet aircraft as being poorly designed, very roughly constructed. Well, that's not necessary. If your aircraft only going to average a few hundred hours in combat, why add all this gold plating, as we call it, to the aircraft? Why don't you make it cheaper, make it quicker to build?
Indeed, a look at welding patterns, for example, helps tell this story. These welds on a MiG-29 look uneven and sloppy, but they are on a non-critical access panel where time and labor-intensive attention just isn't needed. Workmanship on critical structures matches Western standards. Another area where the Soviets' simplicity and maintainability is obvious is in electronics. The Sukhoi 27 instrumentation is rudimentary compared to that installed in an F-16, which was developed also in the late 1970s. Soviet designers bemoan the state of their electronics. They claim their airplanes can accomplish the same tasks as U.S. aircraft, but to do so, they carry a substantial electronics weight and volume penalty, which can degrade performance in range, climb, and payload. The F-16 is the lightest and smallest of the bunch, and it's the one that differs with single vertical fin and single engine. And it's the one the Russians seem the most intrigued with. Valery Minitsky, chief test pilot for the Mikoyan Bureau and one of the most respected flyers in the Soviet Union, attended a recent aerospace engineering symposium at the University of Michigan, along with several design chiefs and the Soviet Minister of Aviation Industry. We asked Minitsky which U.S. fighter he'd like to fly.
Если коснулось бы одного самолета, то я...
If there would be only one, I will choose the F-16C. You see, our company has experience in designing aircraft for different tasks. Being a fighter pilot and a test pilot for jet fighters, I warmly love the lightweight fighters, first of all. I think that it's Formula One in aviation.
The need for the F-16 arose during the Vietnam War, when delta-winged MiG-21s were proving to be a formidable challenge in air combat against the heavier and less agile F-4 Phantoms. The Air Force was looking for a new airplane that could be more effective. The F-15, a larger, longer-range fighter, came into being prior to the F-16 as a match for the MiG-25. But the Pentagon ultimately backed the need for a lightweight fighter, the F-16.
I think it's interesting that Lenin, many years ago, said that quantity is a quality of its own, and so we adopted that as a basis for the airplane. And at that time was strictly to be a lightweight, simple air-to-air fighter, which many people felt was of no use as a consequence of the F-4. Nothing more than a hot dog type airplane to be flown at county fairs on a hot summer afternoon. Concept being so small, wouldn't carry anything, wouldn't go anywhere. Now, there was some basis for that with the technologies that were emerging. I think the F-16 has shown that's not the case. That small doesn't necessarily represent no capability. If you do it right, it's good.
The latest model, the F-16C, has grown in weight and capabilities from its original concept, and now includes beyond visual range radar intercept capability. But still, with its 25,000-pound thrust engine, it has greater than 1-to-1 thrust-to-weight ratio in an air combat configuration. One feature that distinguishes the F-16 from the others is the bubble canopy with no frame or bow and low side rails. Pilots say they feel like they're riding on the fighter rather than sitting in it. The advanced radar in the F-16C can track 10 targets simultaneously. Its computer interprets threat priority and displays targets and friendly forces as well. With such a radar aboard, the fighter needed advanced missiles. Several AMRAAMs, a medium-range missile, can be directed to targets at the same time. This aircraft also has night and all-weather attack capability against ground targets. While F-16 development has taken great strides since it first entered service in 1979, it maintains its unique appearance with one tail fin and one engine. Harry Hilliker, the designer, couldn't do it the other way, even though the original concept for the airplane called for two tails.
When we wind tunnel tested twin tails on the airplane, we could not make it work. In fact, if you look at the shelves that go to the back end of the airplane, there into the horizontal tail, not too many people realize those were left over when we had twin tail airplane. When we couldn't make it work, we went to the single tail, and we could make that work. I've been asked this many times, and the principal answer I can get, and maybe there are two of them. One is that the engine cartel is apparently so strong that they demand each engine have its own vertical tail to tell it what direction to go. The reason that the F-15 and that class airplanes were twin engines, from my perspective, is not from safety. The reason that they were twin engines was because an airplane weighed 40,000 pounds, and when we wanted a 1.2 to 1.4 thrust-to-weight ratio, nobody was making any 50,000-pound thrust engines. And so they had to go to twin engines. They went to two engines pure and simply to get the thrust they needed for the gross weight that the mission demanded and the systems and armament the airplane was to carry. And so to me, one versus two engines is pure and simple a matter of what the mission is, what equipments and armaments you expect the airplane to carry.
Twin tails atop twin engines has become the fighter design norm at McDonnell Douglas, as Irv Burroughs, who made the first test flight in the F-15, explains.
The twin tails have evolved, and you can see the same in the Russian airplanes, through the need for directional stability at high speeds, high Mach numbers and high speeds. And the twin tails allow us structurally to put the directional stability surfaces back there without overburdening the aft end of the fuselage. In other words, we build essentially two booms back to the twin tails, which is more effective than having one single huge tail. It also allows us to position the vortex that's coming off the forward portion of the inboard part of the wings to help us at high angles of attack. The other element that is sort of traditional with us and has become with the comparable Russian airplanes is twin engines. We're a twin engine factory almost, with the exception of the AVAB. But you'll notice there's a difference between our airplanes and the Russians in that our engines tend to be quite close together. In fact, ours are quite a bit closer together than the F-14, for example. We've liked that because it essentially gives you centerline thrust. And an engine-out situation, loss of one engine, doesn't give you an asymmetric thrust problem similar to the one that the MiG-29 had in Paris.
Richard Borowski found F-15s to be a formidable foe in mock air combat.
The F-15, like the F-14, is an exceptional radar platform. Having a good radar today means you've got to be a big airplane because you've got to carry a big radar dish with you. The difference between the F-15 and the F-14 is that while the F-14 is primarily an interceptor, the F-15 is an air superiority fighter. And those words may be a little misleading. What that means is that the F-15 wants to operate in an environment where it can establish a favorable exchange ratio. It wants to not sweep the skies totally of enemy airplanes, but dominate the skies, which means there may be a few of those guys around, but they're all at serious risk. And that's a subtly different mission from what the F-14 does. The F-15 carries a significant amount of ordnance. It has excellent acceleration, rate of climb. It maneuvers very well at medium speeds. The transonic envelope, 30,000 feet, 0.9 Mach, is the heart of the envelope for the F-15. It does excursions away from that heart of the envelope, comes back to that heart of the envelope, and continues to dominate. It's an airplane that is intended to begin engaging the enemy at beyond visual range with the Sparrow missiles and the excellent radar, continue that engagement into sidewinders, in fact, try to engage several enemies simultaneously, and if necessary, it can close in tight and use the gun. The exceptional power of the F-15, as it was originally built and as it exists today with the upgraded engines, allows it to function very well in that environment. The one thing that I'll always remember from mock air-to-air combat with an F-15 is when I thought I had him in trouble, he simply pointed his nose straight up and left the fight vertically, and there was nothing I could do to follow him in the particular airplane I was flying at that point.
How does Sukhoi general designer Semenov feel about the F-15, which parallels in many ways the mission of his Su-27?
Ну, что касается современного поколения самолетов,
and I'm greatly impressed by the simplicity and efficiency of the F-15 design.
While the name MiG is almost synonymous with fighters from the USSR, the Sukhoi Design Bureau, which Semenov currently oversees, also has a long history of building fighters and strike aircraft. But it is the Su-27 which has really spread the Sukhoi name. The airplane, while it looks similar to a MiG-29, is roughly 40% larger in size, weight, and power. The Su-27 astounded airshow watchers at Paris in 1989 when test pilot Viktor Pugachev showed for the first time the Cobra, a dramatic pitch-up and speed reduction maneuver that could offer some tactical advantages in combat. Pugachev demonstrated the airplane to Aviation Week video at Kubinka Air Force Base, northwest of Moscow, and flew for the cameras. The weather was treacherous, with 300-foot ceilings and visibility at about 1.5 miles in fog. His demonstration was flawless. General designer Semenov talks about the design and mission of this airplane, the first fly-by-wire Soviet fighter ever shown to the public.
В этих же целях разработана специальная система защиты.
We designed a special engine protection system which prevents any foreign objects from the ground, from the wheels of the aircraft, or from the aircraft which is in front of this one, to penetrate the engine and to prevent it from normal flying. It is an aircraft designed to intercept aerial targets. In order to achieve this goal, we used the latest achievements in aerodynamics, namely the unstable control system. And we believe that the capacity of the aircraft to cover the distance of 4,000 kilometers and to stay in there for 5 hours is a very good operational feature. If there is an indication of any target, the aircraft speeds up to their interceptor speed and rushes to the interception. Therefore, the aircraft can operate in two modes, that is, interception and loitering for long periods. This way we can compare the Su-27 airplane to Phantom F-4, since it is known that F-4 opened a new era in aviation for the fighters, having about 5 tons of fuel on board. Su-27 has got about 10 tons of fuel on board. We paid a lot of attention to the simplicity of aircraft operation with a considerable angle of attack margin and their margin against aircraft stalling or diving. And, well, the idea behind the design was also to make the aircraft as simple as possible for any pilot, and secondly, to make the aircraft forgive the pilot his mistakes. The aircraft should be able to operate both in the areas where the ground support is considerable and where the ground support is poor. And it is dictated by the idea that in case of a war conflict, the area with with a good ground support can very quickly be turned into an area with a poor ground support. All these factors dictate the mission of the airplane, that is, to be able to operate it with ground support or without support, to be able to detect an intruding target, to follow it, to intercept it, and depending on the set task, either to make it land in the selected area, or if it's a more tragic accident, to destroy it.
Air Force Colonel Borowski, whose area of expertise is aircraft agility, says that from what he sees, he'd feel comfortable flying the Soviet fighters.
I am not ready to say that they are superior to the airplanes that we're flying today. I think it's probably reasonable to expect that they have areas of superiority. That's almost always the case. Again, it's like boxers. Any two boxers that can get into a ring with each other, one of them will have the better long punch, the other will have the better short punch. They'll try to bring the fight around to the place where they have an advantage. Same is true with these airplanes. They will have areas of specific advantage. I can't say from watching an air show exactly what those areas of specific advantage are. You can be sure that intelligence people on our side, on their side, are working very hard to figure out what they are. The tactics people are working very hard to develop tactics to cause them to exploit the areas of weakness that the other airplanes have. We certainly expect that they're able to fly well at low speeds. We understand, have every reason to believe that they have excellent power. And those are two very strong attributes that make them formidable adversaries.
The U.S. fighter that most closely matches the mission of the Su-27 is the Navy F-14. It can patrol for hours, the radar intercept officer scanning the skies with high-powered radar, watching for any approaching threats. As a Navy airplane, its principal job is to protect the fleet and make sure nothing gets past its line of defense. Its long-range Phoenix missiles go after distant targets. The Sparrows are fired when the target gets closer. And for near targets, Sidewinders are also on board. The Tomcat, in service now for almost 2 decades, is the only U.S. fighter with variable sweep wings. Tucked back, the airplane takes on the appearance of a sleek delta-winged fighter, able to maneuver almost as adeptly as airplanes dedicated totally to air combat. But with wings extended, the F-14 has the slow flying qualities needed to get it safely onto the deck. The features that make it land well mean it can do battle at low speeds as well.
Does that mean that the low-speed envelope is a particularly productive envelope for that airplane? May or may not be. In the particular naval environment where the size of the task or of the incoming force is relatively well known, and that size of the incoming force may be relatively small, it's reasonable to believe that you can engage someone one-on-one, slow, with relative confidence that there's not somebody else lurking in the weeds, ready to come into that fight at a higher energy state and prevail.
What also makes the F-14 and most U.S. fighters especially flexible is their aerial refueling capability. Soviet fighters, including prototype naval versions of the Su-27 and MiG-29, just now are testing aerial refueling.
When two airplanes enter an engagement, fuel can, but not will, be the thing that brings that engagement to an end. Obviously, you need to leave that engagement with enough fuel to get home, or you're as good as having been killed, as far as the combat situation is concerned. If you compare American and Russian airplanes have tended to have less fuel on board than American airplanes. Russian airplanes tend to operate closer to home, so that's not necessarily inappropriate. Aerial refueling makes a big difference. If you've just come off the tanker, you have the possibility of entering into an engagement with full fuel tanks. But remember that when you get into that engagement, the engagement is probably not going to last so long that you exhaust your fuel unless you're already low on fuel.
Borowski sees the Navy's other principal carrier-based fighter, the F-18, as an extremely versatile airplane.
The airplane rolls well, it has good high-level attack flying qualities, it accelerates well, it decelerates well. The pilot is generally feels very precisely in control of that airplane. The current trend in flight control systems is for a multi-mode flight control system. The airplane actually flies differently depending on what mission you're doing. It can be optimized to fly a precise track through the air, or it can be optimized for precise pointing in the air. And of course, let's say you're shooting a gun, you're aiming a missile, pointing is more important than the track you fly. If you're delivering a bomb, the track you fly through the air is extremely important. And those kinds of changes can be within the flight control system today. The F-18 being a later airplane uses later flight control system technology, and for that reason is probably the most versatile of the airplanes flying today.
Of the U.S. and Soviet fighters, the two that most closely compare in an air combat role are the F-18 and the MiG-29. They match closely in size, weight, fuel capacities, and looks. McDonnell Douglas is acutely aware of the MiG-29's similarities and differences.
The MiG-29 is an airplane of about the same size as the F-18. And about the same vintage, by the way, late 70s, I believe, mid to late 70s. It has a high thrust to weight, probably a little bit higher than the F-18. I believe it's probably more better than 1-to-1 on takeoff. And it has an interesting characteristic in that it's a pure old hydraulic mechanical flight control system, where our airplanes, if they're not pure fly-by-wire, that is no mechanical connection at all, they at least have a fly-by-wire system overlaid on the mechanical system. That's the way the F-18 is. So we are essentially flying that airplane electronically. They're flying the MiG-29 hydromechanically, the same sort of thing the F-4 had years ago. So the fact that they're able to do the things they are with that airplane speaks well for the aerodynamics of it. I suspect it's a higher top-end top speed. I believe it is 2.3 than the F-18, so it does have that advantage. On the other hand, it's, as I described in the Su-27, a very archaic cockpit, even more so than the Su-27. They're back in the F-4 days relative to their cockpit technology on those two airplanes. It clearly doesn't have the air-to-ground capability that the F-18 does. I say clearly because we've never seen any evidence of that sort of capability in the airplane, and they typically will talk about the sort of thing they can do, and they haven't. It's a single-place airplane, except for their trainers, same as the early F-18s, and has some of the very same characteristics to look at as the F-18. Some physical characteristics are the same. The leading edge extensions from the wing roots are typically F-18. The twin tails are very similar.
Don't for a minute, however, think that the MiG-29 is just a knockoff of a fine U.S. fighter. The MiG Design Bureau has been in the fighter business since World War II, and some world-class airplanes have come off its drawing boards. Standouts include the MiG-15, the MiG-21, MiG-23, and MiG-25, the fastest fighter in the world. Which served as the basis for the current MiG-31, still one of the most classified aerial war machines in the Soviet fleet. A long-range, high-altitude interceptor that can dash at nearly Mach 2.5 and dominate hundreds of square miles of airspace. Rostislav Belyakov, now general designer of the Bureau, and with 50 years of service there, prides himself on his team's accomplishments and on the MiG-29.
The MiG-29 was designed to change the previous generation, to switch from previous generation of Soviet frontline fighters such as the MiG-21 and MiG-23 to rearm the frontal aviation. And so, of course, we used all the experience gained on the previous programs, and we especially strengthened its agility and its capabilities in a close dogfight. And we think that the combination of thrust-to-weight ratio, initial climb rate, maneuverability, maximum speed at low altitudes, and, well, maneuverability as a whole I think that this combination of the MiG-29 surpasses the same features of any aircraft existing in the world now.
Имеющиеся в мире.
He concedes the difficulties, however.
Хотя мы заплатили за это большим миделем.
But of course we paid a certain cost to obtain these capabilities because we have, well, a cross-section that is overlarged to ensure a high air consumption for high-thrust engines, and also we have well, a bubble canopy that also increases drag, but we used it to ensure pilots' visibility.
And limitations in electronics technology clearly bother Belyukov.
Терять или уступать
to achieve the technological parity with the Western designs, we had a harder job to do because our electronic industry lags behind, judging from the Western standards. So we should give more volume to the electronic devices of the same level. And that's why our aircraft having the same overall efficiency would usually be heavier than the Western aircraft of the same efficiency. And of course it increases the cost of the overall program, because the cost of the program usually very closely follows the weight of the aircraft.
A detailed review of the MiG-29 shows how its design fits molds created by Soviet doctrine and history. Soviet aviation expert Dick Ward explains.
So many of the Soviet design criteria for their aircraft are not based on what happens when the airplane's flying, but when it's on the ground. The landing gear design is based heavily on sod fields, and so rather than design the lightweight landing gear, they design the most rugged landing gear. Inlet designs are based on foreign object damage. Plus it has bypass inlets to be able to run the inlet air for the engines coming in over the top of the aircraft during takeoff and landing.
The Soviets used containers to store fighters in a near-ready state, and also to ship them from remote sites to factories for overhaul. The MiG-29 had to fit the same container as earlier fighters.
And in doing so, they had to design the engine to be shorter than would be optimum, and they had a time of development, extended development or difficult development on the afterburner of the engine trying to meet this length constraint.
Towing and shelter constraints meant wingspan limitations. The MiG-29, with its outer wing panels removed, is shown here between a MiG-23 and a MiG-21. Abbotsford, Canada's air show in 1989 featured the first MiG-29s ever to be displayed in North America. A quick friendship between a Canadian F-18 escort pilot and a Soviet test pilot led to one of the most remarkable events in recent aviation history. Major Bob Wade was ultimately allowed to fly the MiG during the air show, with Valery Minitsky, chief test pilot for MiG, in back.
Ну, во-первых, Bob Wade.
Well, Bob Wade actually performed the whole flight by himself, from takeoff to landing, and just a few corrections from my side. And I should mention very high skills of Bob Wade, because everything that we did in 12 minutes only. I have not very good English, and Bob doesn't speak Russian at all. But you see, we were both professional pilots, and we have excellent knowledge of what we wanted. So we had no problems during the flight.
I think what I expected was less quality in the MiG-29 than what was actually there. If I was surprised at anything, it was the performance of the airplane, or the performance capability of the airplane, when it appeared to be so rudimentary in construction. In an engagement that was 1v1, F-18 against MiG-29, the biggest single factor that would decide the outcome was the training and proficiency and competence of the aircrew themselves. Both aircraft would have areas of advantage. The MiG-29 perhaps in speed, where the F-18 would be able to display more information simultaneously, would be better capable of employing weapons perhaps, especially at short range, because of the sophisticated technology incorporated in the F-18. I think the MiG-29 pilot would be busier flying the airplane than what a pilot from a fly-by-wire system would be, because it physically demands more of your time. I think the MiG-29 pilot would be busier trying to assimilate information because he has less access to it. The problem with systems like the F-18 is that they display too much information to you. You require experience to know when to prioritize or how to prioritize that information coming into you. So that it's very easy to become saturated with information flying an F-18 and disregard the important thing. But I think the biggest single deciding factor as to who would win the majority of the fights 1v1 is going to be pilot experience, pilot competence.
Aviation Week and Space Technology magazine for months had been requesting access to Soviet fighters. On a snowy January, with the flight almost scrubbed by the Russian winter and snow-covered runways, Dave North, managing editor of Aviation Week, got his turn in a MiG-29 at Kubinka, a MiG-29 air defense base west of Moscow. North, a former Navy attack pilot with over 100 missions in Vietnam, was about to become the first journalist to fly the airplane. Snow had fallen all morning and low clouds remained, as shown on the hand-colored weather maps prepared by the base meteorologist. By mid-afternoon, with early darkness approaching, North was on board, back seat due to the poor conditions, with test pilot Minitsky up front. Soon, they roared off the 8,000-foot strip and disappeared into the low clouds. Their flight lasted about 40 minutes.
Well, it was a very agile aircraft. The combination of the power and the agility and the flight control system was very good. It's a manual system, but it reacts much similar to a fly-by-wire system. Well, the tail slide, other maneuvers where we went to 30 degrees angle of attack, zero airspeeds, where you had flight control ability throughout the maneuver, told me that the lateral stability of this airplane, or the ability to control it at very slow speeds, is excellent. And it's a very high-performance, fast aircraft. We didn't get beyond, we could not get supersonic, but the low speed characteristics are excellent. We did the tail slide several times, where you achieve zero speed and actually come back down on the tailpipe for about 3 to 4 seconds at the max, and then go into burner. Once we went into afterburner, and once we went to military power, and again, as we're coming down and going to the increased engine power, there was no faulting or no stopping of the engine whatsoever. There wasn't even a cough. I found the MiG-29 to be a highly maneuverable aircraft with very good responses from the flight control system, and also a very good meld of engine power that never faltered during some very demanding maneuvers.
The MiG-29 and its Western counterparts are the latest in air superiority today. But what's coming? What will give these airplanes and their successors an even greater edge? The Soviets won't say much. A fly-by-wire neutral or negative stability MiG-29 is now being tested. At the Sukhoi Bureau, testing is underway of a sea-based version of the Su-27. It's been making carrier landings and sloped ramp takeoffs from the carrier Tbilisi for months now, and features a canard wing up front for enhanced low-speed control. But Dick Ward, the Soviet air operations analyst, is looking farther into the future. In the mid-1980s, Ward reviewed the history, developments, and technology at the MiG Design Bureau and published a booklet called MiG 2000. 2000 is the year Ward predicts the next radically different MiG fighter will go into service, the hottest one yet, with speeds of nearly Mach 2.6, thrust to weight nearly 1.4, internally stowed weapons, a moderate degree of stealth, and short takeoff and landing capability. Ask General Designer Belyakov what he's up to, and he says to ask Dick Ward. At McDonnell Douglas Aircraft, they're applying some of these techniques in the F-15 STOL and maneuvering technology demonstrator, now undergoing flight test at Edwards Air Force Base. It sports a canard wing up front for better high-angle capability. But its most notable, if not so obvious features, are movable 2D thrust nozzles. Developed by Pratt & Whitney, they also offer reverser capability for dramatic impact on speed and pitch. These new features can combine effects to give the F-15 demonstrator the capability to take off and land within 1,500 feet. Richard Borowski is involved in the aircraft tests.
What that means is that you come blowing into a fight at a relatively high speed, Mach 1.6 or so. And then, having launched your missiles, you want to slow down very rapidly so that you can make a very tight radius turn and then get out of there as quickly as you can so that you don't need to engage at close range. The STOL demonstrator with in-flight thrust reversing makes that possible. With thrust vectoring, we're able to use the thrust vectoring to pitch the airplane, make the stabilator again available to make the airplane roll, and the airplane at relatively high speeds, relatively high G loadings, which is really the heart of the air-to-air combat envelope, will have a much better capability to roll while simultaneously pulling G. That allows you to change the plane of the fight, and changing the plane of the fight allows you, if you can operate in a plane that the other guy is not in, it's very difficult for him to bring his weapons to bear on you.
McDonnell Douglas also is developing a cockpit display concept to help give fighter pilots a better picture of the aerial battlefield and deal with it on a single screen by touch, voice, and perhaps by brain activity. There are no buttons or knobs. Gene Adams is designing the display.
We looked at the conventional warfare environment of the 90s and realized that the only way we could show a pilot the complex interrelationship of all of the aircraft, surface-to-air missiles, and his mission plan was to overlay that data on top of a map and put it on a large display. And we knew that the computer generation and video generation pilot would readily accept it.
The secret work continues toward creation of the Advanced Tactical Fighter, or ATF, a high-altitude interceptor that analysts say someday may replace the F-14 and F-15. Two teams are building prototypes. The one from the Lockheed General Dynamics Boeing team may look like this and is likely to include new airframe materials, next-generation electronics, some stealth technology, supersonic cruise, and high angle of attack maneuvering capability. The prototypes are expected to begin flying this year. In Europe, a consortium of companies from Britain, Germany, Italy, and Spain is developing an air superiority fighter for those countries called the European Fighter Aircraft. The Eurofighter, scheduled for service in 1996, is a single-pilot, twin-engine design, similar in size and weight to another new fighter coming out of Europe, the Rafale, from Avion Marcel Dassault. The French company introduced the show-stopping Rafale in 1986 as an initial prototype of what is to become a fighter attack land and carrier-based airplane for France. It's a full fly-by-wire airplane, single pilot, with speed capability exceeding Mach 2, and is also scheduled to begin service in 1996. A new lightweight fighter demonstrator soon to be flown is designated the X-31 and developed under the guidance of the U.S. Defense Department and Navy. Rockwell International and MBB of West Germany have built two X-31s, and the first one rolled out in March of 1990. The airplane will have Mach 1.3 cruise capability, but is designed to have an exceptional degree of control authority at low speeds. It relies on thrust vectoring paddles in the jet exhaust to enhance maneuverability and control. Designers expect it to be able to rotate around its yaw axis at angles of attack as great as 90 degrees for dramatic course reversals, which would give any fighter airplane that might evolve from these demonstration airplanes a tremendous air combat advantage. The stealth fighter may have been, until these films were released in April 1990, the best-kept aeronautical secret since the SR-71 Blackbird. Its impact on air combat is just now beginning to be realized. Built by Lockheed and designated the F-117A, the Dart-like airplane has a single seat and 2 engines. Relying on material, design, elaborate electronics, and special flight techniques, the airplane presents a minimal target on radar. In fact, according to sources, the stealth fighter's radar image on even the most elaborate radars is smaller than that of a large bird. The F-117A first flew in 1981 and became operational 2 years later. Now, nearly 60 stealth fighters are in Air Force service, assigned to the 4450th Tactical Group and based at Tonopah, Nevada. Its first combat mission was during the December 1989 invasion of Panama. 2 F-117As flew a nighttime mission over Rio Hato and dropped 2 2,000-pound bombs to disorient Panamanian troops before the base there came under attack by Army Rangers. Some observers have suggested that stealth will mean the end of air combat as we know it, that these high-cost fighters will sneak up on a target, do their job, and run home. But other analysts, including Dick Borowski, suggest just the opposite. Stealth may mean the potential for more close aerial engagements. They reason first that the pilot in a stealthy airplane that's hard for his opponent to see has the capability to get closer if he chooses. Second, stealthy airplanes may sometimes run with radar off to avoid detection. In such a case, 2 stealth opponents may find themselves much closer in to each other before they're aware of the mutual threat and begin the engagement. So stealth would tend to drive air-to-air combat closer. At this point, the Soviets suggest they have no stealth airplanes and would prefer not to develop them. They are behind in stealth technology, and current economic and political problems in the Soviet Union make stealth development all the more unpalatable. They wish stealth would just, well, disappear. That, of course, is unlikely. Air superiority results from no single component, but from a complex mix of elements that make up today's fighters. The onboard radar, the weapons, the cockpit, and how well the pilot can see the situation around him. The threat assessment equipment aboard, and how effectively it presents information to the pilot inside. The ability of the airplane to respond to the pilot's needs and wishes, or more simply, the fighter's agility, and ultimately the pilot himself and his training and ability and will to use all of these elements to maximum advantage. Perhaps no task is more demanding than that of the fighter pilot in battle. Who knows how that job and the tools of the trade will play out in